Welcome back, and now we will see a project on image compression with k-means clustering. On this project, basically what we do is the compression of images based on colors. Like by the millions of colors in the images, this will reduce that colors to your desired value of colors. Here I have taken initially reduced our image to 16 colors, but you can change that by doing the modification of number of colors. And the procedure I have applied here, the k-means clustering unsupervised machine learning algorithm using scikit-learn and Python to build an image compression application. So let's start. First, we need to import all the important libraries. Like here we are importing NumPy, Pandas, Matplotlib, sklearn.cluster import k-means. We are going to use k-means algorithm, and from sklearn we are importing shuffle. Shuffle will shuffle our data randomly. And here time module also we have taken to check the how much time our algorithm will take. So I'll just run this block by hitting shift enter, and then here I'm setting the number of colors is equal to 16. You can change number of colors as per your desire. So here I'm taking 16 colors, and the first thing I'll just going to check my input data. Here my input data is a image. I'm taking an image and going to reduce the colors inside the image. So here tiger is equal to plt.mread using the matplotlib, just reading the image tiger.png, and then showing the image plt.mshowTiger, access is equal to off plt.show. So you can see this is the original image I'm taking. You can take any image whatever you want. And the second step is an alternative to read image. There is another module inside the Python is OpenCV. We can read the image through the OpenCV also. So this is the just another way to read an image. So import CV2. For this you need to install the CV2 also. Here I have just already installed OpenCV, so just I'm using import CV2, and then tiger is equal to cv2.mread tiger.png, and by default CV2 taking the images in the form of BGR color format. So we need to change the color format cv2.cvt color tiger comma cv2 color BGR to RGB. And then there's simple figure, access of title and mshow, and then plt.show. This is the optional step, and don't be panic if you don't know about the OpenCV. Don't worry. This is just simple step. I'm showing how to read the image through the OpenCV. Okay. Now we will analyze our image. What inside our image? What are the dimension of our image, and how our image data is look like? So you can see tiger.shape, our image shape is 693, 1232, 3. Means we have width, height and colors. So we have RGB color format, and then we have width and height, these number of pixels. So basically this is our image shape, and now we will see the pixel value. Our image will contain the pixel value ranging between 0 to 255. That represent the intensity of every pixel. So you can see, you can print tiger. Tiger is basically a NumPy array. You can see the output here, and this NumPy array contains certain values ranging between 0 to 255. Okay, you can see our pixels having the values that is in range of 0 to 255, and machine learning algorithms works good if our data range is very small. Like we just want to standardize the data by dividing 255. If we will divide every pixel by 255, then our data will fall under the category of 0 to between the range of 0 to 1. So here we are doing just standardization of the data. Tiger is equal to tiger divided by 255. And you can see the output. Here our data, the pixel values are in between 0 to 1. This is our data we are going to use. Now, k-means algorithm takes only the 2D image, not the 3D image. We have 3D image that have width, height and color. So we need to change from 3D to 2D image by combining W into H for the k-means algorithm input. Here we are not merging the color because we are going to walk over the color. That's why we are merging width and height. So first we will store shape inside three variables because after the clustering we need to recreate the image also. That's why we are keeping the image shape here inside the W, H and D. So tiger.shape is equal to W, H, D. And we are reshaping the image tiger.reshape W into H, D, and this is we are storing inside image underscore array. And now you can check the image underscore array shape. This is the shape width into height, color. And this is very big image. So what we will do, we will take a sample image and we will train our model over the some short subsample of the complete image, and then we apply the k-means to the complete image. So here you can see we just imported the time, just checking how much time this algorithm will take, and then we are taking the first 1000 pixels of this complete image. So taking only the 1000 pixels, our image inside the image underscore array. So image underscore array random straight is equal to 0, and we are taking the first 1000 pixels. First we are shuffling the image, like all the pixels we will shuffle. Here first we are taking the complete image underscore array, and then shuffle the image pixels, and after that we are taking only the first 1000 pixels. So you can say we are taking a small subsample of the complete image, and then this small subsample we will train to the k-means algorithm. So we are importing the k-means. K-means a number of clusters is equal to number of colors, and we have defined number of colors is equal to 16. You can change as per your requirement, and random straight is equal to 0. So this is our algorithm k-means, and now we will fit our image to k-means algorithm. K-means dot fit, and in this fit function we are passing the sample image, and then we can check how much time this will take to train k-means algorithm. This is taking 0.203 seconds. Okay, now our algorithm is prepared, and we get the labels for all the centroid on the complete image. So k-means dot predict, and here we pass the complete image, and you can see the labels we are getting like this 66370. So labels we will get in the range of 0 to 15 because total number of clusters we have taken 16. And we can also check the cluster centers. You know how many cluster centers we have? We have 16 cluster centers. K-means dot cluster centers, and these are the basically our cluster centers. Okay, and labels, total labels we have as many pixels we have here. You can see total labels we have 853776. And if you want to check the first label, what is the first label? First label is 6, means first pixel is assigned to cluster number 6. And we can check the shape of our cluster centers also. Shape is 16,3. Now we have created the algorithm, and we have applied the k-means algorithm to the image. Now what we need to do, we need to recreate the image. Like our original image having some color components, and now we are going to recreate an image with only the 16 color components. Okay, so this is very important part and little bit difficult. Just try to understand. I'll teach you in very simple manner. So recreate original image according to the labels and each pixel. Basically what the concept I'll follow, like our first pixel is assigned to 6th cluster, means at the place of first pixel I'll put the value of 6th cluster center. So our image having total pixels like 856776, something like this number, you can say 1000 pixels. So these 1000 pixels will be assigned to only the 16 values. Like every pixel value, we will assign the pixel value according to the center value, cluster center value. Basically initial level our image have different pixel value, and now we just want to cluster into 16 clusters. So how to cluster? Basically, every pixel will have cluster center value. Suppose 10th pixel assigned 5th cluster. So in place of 10th pixel value, we will assign 5th cluster center value. Okay, now I think it should be clear. Now let's see the function def recreate image, and inside this function I'm passing C means centers, like our 16 centers, and labels, total labels to all pixels, and then width, height and depth of the image. Now again 3D to we are going to convert our image from 2D to 3D. So we create an image, zeros image. So numpy array, we are creating here numpy array, zeros numpy array with a dimension w, h, d. This is image. So you can see image is a zero array, but size is w, h, d, original image size. And here we are taking an index variable, labels underscore index is equal to 0. Now we label each pixel according to the limited labels, 16 labels. So we are traversing our image for I in range W and for J in range H. We are going to traverse every pixel. Okay, so these two loops we are running, and then here this is important thing, like you can see label underscore idx. Initially label underscore idx value is 0. So labels of 0 means first pixel label, and first pixel label, suppose we have assigned here first pixel label is 6. So C of 6. So center of 6. Sixth centroid value will be assigned image I of 0, first pixel. You can print these variable. I have just commented here so that you can clear the picture. And then we are increasing the index value. Index is equal to increasing by 1. And here we can print the index and we can return the complete image. Again, if you will run this loop like for total width, then J value will be incremented. So image always traverse from top left corner. First it traverse the rows and then it come to the bottom columns. So first pixel and then second pixel, third pixel, like this, it will go from left to right and top to bottom. So our J value is changed, and this time label IDX value is 1. So label of 1 means second pixel value, and second pixel, what the label assigned to the second pixel, we will assign the centroid value of that label. Okay. Similarly, we will traverse complete image and finally we will return our image. So I can run this block and now I'll call this function. So here I'm plotting the original figure, axis is of original is tiger. So plt.im show tiger, and then the figure 2, and in the figure 2 title is reduced, and plt.im show recreate underscore image. This function recreate we have already defined, and now we are calling recreate, and inside this we are passing C labels WHD. So this will return you the complete recreated image. And now I can run this block and you can see the output. Like I'll just scroll, and this is the original image and then this is the reduced image. You can see the difference. Okay. So like this we can reduce number of colors using k-means algorithm. This is one of the application of k-means algorithm. Okay.